Okay, now after some machining processes as well as machining fluids, now we are moving to the practical machining processes in this particular course and in particular in this class. Okay. So, what all we have done in the classification of machining process, single point, we have done turning process, that is a basic machining process we have done, and we are moving to another practical. So, if the classifications is single point cutting tool, multi point cutting tool and abrasive process, all processes we will deal in this particular course. Till now we have conducted the lectures on the turning process, which is also a basic machining process where you can understand the basic physics in the introduction as well as the machining fluids in particular, slightly in deep analysis. So, now we will move on to the other processes. In this particular class, we deal with boring, shaping, planing, threading and the taping, broaching and sawing. These are the processes that we are going to take up, and these are also called as some of the practically applicable processes. I mean to say that turning is not a practical process. Move ahead, these are the other processes that are practically useful. Now, we will move to some of the single point cutting tool process, some of the multi point cutting tool process, and which are, it is named in some of the books like a practical machining processes. So, that is why I also called it as a practical machining processes, and so on. We will follow in the next class other multi point cutting tool processes and followed by the abrasive processes and all those things. Now, we will go to the boring process as a first process. If you see the boring process, it is normally looks like this, just, and I will explain you that boring process is producing the circular internal profiles hole made by the drilling process. That means that you required a pre-drilled hole. Normally, boring process is to enlarge the existing hole. For that purpose, you should have major amount of times. Some of the special cases it's okay, but normally if you have a existing hole that is drilled and you can enlarge that hole, that is called as a boring process. The single point cutting tool is called the boring bar, which is along with the shank. Now, if you see here, this particular thing is nothing but the boring bar, including the tool. The boring bar can be rotated or in the workpiece can be rotated. Both things can happen. If at all I want to rotate the tool, I can rotate it. If I want to rotate the workpiece, I can rotate the workpiece also. Normally, in case of lathe, if you are doing by the boring by the lathe process, the headstock will rotate or revolve, so the workpiece will revolve. The machine tools which rotates the boring bar against the stationary workpiece are called the boring machines. They are specially called boring machines and also called as boring mills also. So, can be accomplished in the turning machine also by keeping the stationary boring bar positioned, but the workpiece can be rotated. So, that means that the boring tool or the boring bar can be held in the tool post as a stationary, and you can rotate your workpiece so that you can do this boring process. You can see here, this is a lathe on which the chuck is held, the workpiece is held in the chuck, and the cutting tool which is called as a boring bar is stationary and it is drilling happening. That is about the boring process. So, existing there was a small hole, now I want to enlarge the hole in this particular thing. Previously, it may be like this, where it can enter, then it is enlarged to this particular dimension. Okay. That is about the boring process. Okay. So, if you see the schematic diagram of the boring process, this is the boring bar and this is the work part or the workpiece, work table is there. In the previous case, it is workpiece is rotated, now the boring bar is rotated, so that you can get the enlargement of the hole. That is shown here in the schematic diagram. So, these are the boring bars. If you see the boring bar, there are different varieties of boring bars which are nothing but the cutting tools that are used in the boring process. You can use the HSS single point cutting tool where you can do the boring bar by using a tool and cutter grinder as per your requirement and all those things. For that purpose, only thing you have to do is you should know how to utilize, how to make particular shank or the blank that is given by the supplier, which is a HSS material, just you go to the tool and cutter grinder as per your drawing, you can change to this one. Commercially available boring bars are there, just you can use this to make the bore. So boring machine types, normally there are two varieties, one is a horizontal boring and another one is a vertical boring. So you can use horizontal also or vertical also. Okay, this is about the two. Normally the cutting fluids, since it is the machining and machining fluids, so we should also look up at, we also should look at the cutting fluids that are used. Normally you can use both because the boring process can be slightly lower cutting speeds compared to turning process, or some people they may operate depend on the tool material. If they have a very good high hardness tool material, they can go for higher speeds also. So you can go for the pure lubricants also as well as emulsion types also. In this one, if you see, it is looking like a milky color. So the whatever the cutting fluid they have used is a cutting fluid emulsion. If you see, in the some other cases, you can go for the higher amount of pure lubricant oil with low amount of water. So the lubricating properties will be better in boring process. Okay, so this is about the boring process. Now we move on to another practical process that is called threading. Threading is nothing but making of threads, internal threads as well as external thread. So the threading is a helical shaped groove formed on a cylindrical surface of the workpiece. So it is a continuously formed helical groove. So thread cutting operation is performed on a lathe to produce the threads by using a tool whose shape will be same that other thread. Okay, assume that I want to make a thread shape, so you have to have the similar type of shape on the tool also. Okay, so external threads are provided on the bolts, screws, while the internal threads are incorporated on the nuts and any other machine members. These are the two varieties. If the functionality of the fasteners are threaded for the holding the component. Normally, if at all I want to hold the component, for that purpose these threaded components are used. If you see the picture, this is how the thread look like. So it will have a pitch, it will have a lead, it will have a, normally this is a root, pitch, crust to crust is nothing but a pitch. There are single start, multi start threads also there. So depth of the thread is there, and this is the crest. So one crest to another crest, if normally the distance is normally known as a pitch, and the lead is nothing but how much it will move in one rotation. Okay, if it is a single start thread, normally it will move lead equal to pitch. If it is a multi start, you have to multiply by that multi, what is the which is specified by n. So helix angle will be there, and the major diameter of the thread, minor diameter of the thread, and the pitch diameter also will be there. This is major diameter and this is the minor diameter of the thread, and you will have also the pitch. Okay, so you will have the minor diameter, major diameter as well as the pitch diameter. So this is pitch diameter also, you can say it is as the mean diameter of that particular threads. Okay, so now we will have also have the thread angle. Normally in this one, the commonly used or commonly explained threads are like V threads, where you will have a 60 degrees, you can see, which you can divide into 30 and 30 here. So you will have normally single start thread, multi start thread, that was I was talking about, and I will explain you what are the single start, multi start and all those things. So the thread cutting or the thread manufacturing can be done by various techniques. First and foremost basic technique is thread cutting using lathe, thread chasing using a chasing dial, die threading, tapping is there, thread milling is there, thread rolling and thread grinding, thread casting and thread whirling. All these are the varieties of the manufacturing techniques of these threads. So whatever you can see here is the simple techniques, that is what I have explained in the previous slide also, that is called the thread cutting by the lathe process. In a lathe machining process you can cut these threads. So the principle to produce the helical groove on a cylindrical or a conical surface by feeding the tool longitudinally when the job is rotating. That is how you can generate the threads on the lathe by using a lathe machine. Screw threads, there are three varieties or multi varieties are there. Normally in the common practice we will have single start, double start and triple start. So wherever if you see single start, normally lead equal to pitch, where pitch if you multiply by 1, normally pitch will be pitch only. So that is nothing but it is called a single start. If you have lead equal to double of the pitch, that means a double start, and if you have lead equal to multiply by 3 into the pitch, that means it is called triple start thread. Normally why we have to go from single start to triple start? People, the students may know there is about single start threads are there, double start and triple starts are there, but the practical use of this one is if at all I want to open certain caps or something. So if at all I want to put less energy and I want to get more outcome, there you will normally the people go for the double start and triple start. If you, for example, if you see the some of the cool drink bottles, if at all if you rotate in one go, it will may come. Some of the bottles may not come. So those come wherever you just rotate in one go, automatically complete it may come out. That is called, the technology they may use is a double start or triple start. So if you put less energy or one rotation itself, it will come out. But if you tighten it also, it in one rotation itself, it will tighten perfectly. So if at all I want to open with less amount of energy and tighten it with less amount of energy, you have to go for multi-start thread. So if in a single start thread, it will have long time. So it has to go and go. So it go on, it will be there. Okay. For that purpose, normally multi-start threads will be used. So thread manufacturing, the another process is milling process. You can also do by the milling cutter. The threads can be produced by the milling process also, that is using the form cutter. So depend on the shape of the threads that you want, your thread cutter you will choose. Okay, the form you can choose depend on your requirement of the threads. Okay, so that's why you will use the form cutter. So normally when this is suitable is when producing external thread which are suitable to cut with the tap, not with the tap. That means that if we are unable to cut using the tapping process, the tapping process you will come across in the upcoming slides in this particular class. So where the threads are not in a position to cut by this tapping process, you can cut external as well as internal. So I am talking about external in this particular slide. If you are unable to cut there, you can go for this one. So normally if you have a very big diameter, then you can go for the thread milling process. Work that I said, no, large diameters beyond the capacity of a die. If the die is cannot do, not normally you can go for the thread milling process. So thread milling, it is a cold forming process for making external threads on a cylindrical surfaces, and the threads are formed into the blank by pressing the thread rolling against the die or a blank. Normally you can use this one. This is what I am talking is not about the milling, it is called what I am talking is thread rolling process. Okay, rolling process is a cold forming process for making external threads on a cylindrical surface. Threads are formed into blank by pressing the rolling against a blank. If you see, it is a faster method of the production. Skilled labor is not required, and it is a chipless operation. There is no chip. That means that there is no material wastage. Like in a metal cutting process, you will get the chip wastage, that is material waste in form of chips. So here it is a material. It is a metal forming process, so you don't have any chip formation, so there is no loss of the material. Threads are produced by rolling process of good quality and high accuracy. So whatever the things you are going to get will have a better accuracy and good quality. Thread rolling increases the tensile as well as the fatigue strength of the workpiece material. That means that whatever the output that I am going to get will have good strength, I mean to say tensile strength as well as fatigue strength also. So, but the problem with this thread rolling is it is limited to the ductile materials. Means the material should plastically deform easily. The ductile deformation should be there. If it is a brittle material, what will happen? It will fracture and it will damage the workpiece. So, the threads may not form on the particular surface. So, thread rolling, you have a two type of varieties. One is cylindrical, another one is a reciprocating flat die machines. This is called flat die manufacturing process, where two dies are used. One is at the bottom die which remains stationary and other is a reciprocating die. What is I mean to say is, this is the fixed one and this is a moving one. So, you can reciprocate here, so that this is your workpiece. The threads are formed on this one by metal forming process, where chip is not there and all those things. The another process is cylindrical die manufacturing, where you will have the die on one side, another one is a workpiece will be there at the center, then you will have another support and you can generate it. Cylindrical die machine uses 2 or 3 dies, depend on the requirement. You can use 2 or you can use 3 also. So, in case of 2 die machine shown in the figure, the blank is supported between the dies and these 2 rollers are rotating. You can see here, there is a directional symbol is given here. There is a directional symbol is given. So, these are rotating against the workpiece that is there here. This is the workpiece. The threads are formed on the workpiece. So, this is called cylindrical die manufacturing. Both these are all metal forming process. Okay. These are all metal forming process which are not metal cutting process that we learnt in the previous lectures or in this particular lecture also. That is the only difference you have to make sure about this particular slide. Another method is thread casting method, where casting all of you may know, because it is one of the primary manufacturing process, where you can take the cavity of the mold, then you can make it, like you just melt it and you just pour it into the cavities. The threads are made by the sand cast, are rough and not used for exceptional wires and rough machineries. That means, what I mean to say here is, sand casting type of threads, if you are somebody is manufacturing, those are very rough and not used in precision applications. Those are used for rough machinery application. Compared to the other casting, lost wax method is one of the casting methods. As you know, this gives the good surface finish but costly process. This is slightly costly from the point of manufacturing of this. So, other thing that I want to specify this particular thread manufacturing by the casting process is, due to poor accuracy, casting threads are used in such areas where threads are very short. Okay. So, small length, if somebody is producing, that is where normally the thread casting process is used. So, the precise things that if you want, you have to go for the thread cutting operations only. So, if at all you are going for a casting operation, there is a problem, because the sand casting, the surface is very rough, and if you are using this as a nut or a bolt, then what will happen? The accuracies are not maintained. For that purpose, normally you can go for again the rough machining process, or you can go for making it as a some low precise operations. For that purpose, you can go for thread casting, the threads that are manufactured by the casting process. Okay. So, if you see thread whirling, so whirling is form of the is nothing but a thread milling process, where you can have the cutter inside a ring. This is the ring. the cutter will be there inside, which is the tool cutter holder rather than outside that one, and you can rotate it. Okay, so you can rotate the workpiece, and if the threads will be formed. Okay, once you rotate the workpiece, then you will get the threads on it. So advantage of this one is you can get the deep threads. Assume that I want very high depth threads, you can go for faster process. You can go for, if at all I want at very less time, normally you can go for this one. Then increase tool life. So tool life will be high, that means that the tool wear is less, and increasing productivity as your setup time is faster. So obviously your production time will be saved and the productivity will be increased. Okay. So if you see the cutting fluids in the thread manufacturing, normally thread manufacturing, one thing, whenever you go for thread cutting using the lathe process, in that circumstances, normally there was one thing you can note, that is nothing but the cutting speed that you will use always will be much lesser compared to the turning process. If the speeds are much less, what will happen? The friction plays a major role rather than the cooling. In that circumstances, majority of the cutting fluids, they will use the mineral oils, where emulsification is very negligible. That means that if at all some people want to use the water, so they will be using very minimally, or you can directly go ahead with the pure lubricants. You can see here the pure lubricants are used for cutting the process. But I said no, if at all you can go for the emulsions. Here the emulsions are used in this particular figure 1, emulsions are used, but you can use it. But the thing is that if the speed is too low, what will happen? Friction is the major. So friction can be countered by the lubrication action. So that is why normally you prefer the lubrication action, that means less water or without water type of cutting fluids will be used in the thread cutting process. You can also see here, so emulsification, as whenever if you want to cut at higher speeds, normally there is a chance of thread failures and all those things. There you can go for the emulsions, or some of the people they will also use dry cutting also. So if you have a very low strength material like aluminum or something, then they may not be required of your coolant and all those things. In that circumstances, dry type of thread cutting also will be used. So this is flood cooling type of used, and I said mostly this is the lubricant type of thing. That is what the most of the cases, if you see the thread rolling process, you have seen cylindrical, flat die and all those things. In case of thread cutting also, you will use the pure type of lubricant. You can see here the completely it is the lubricant. So lubricant or mineral oil based cutting fluids is used in the thread cutting process or thread rolling process. Okay. So that is what about the cutting fluids or the machining fluids that are used in the thread cutting process or the threading process. Now we move on to the tapping process. So where the tapping process, if you see the tapping process, the schematic diagram or the sectional view also you can see here. So this is the tap and this is the workpiece, where you can generate it by the machine or you can also generate by the hand also. There are the taps hand operated, there are the taps the machine operated also are there. So one by one we will see. Introduction to the tapping process. Tapping process is the cutting a thread inside a hole so that the cap screw or bolt can be threaded into a hole. That means my prerequisite is I required a hole to make the tapping process. If there is no hole, I cannot generate the threading on particular workpiece. That means that I cannot generate the threadings if there is no hole. So I required a hole on which I can generate the threadings. Tapping is done with a tool which is called tap. So you can see here, this is called as a tap. The tapping operation, it can be done by the hand tapping lathe machine also you can use, milling machine also you can use, and tapping machine also you can use. There are 3 varieties of taps you can get, and the tap is used for internal as well as external threadings. So whatever you are seeing here, this is what is here, and this is what the internal threads are generated here. At the same time, you can see here 1, 2 and 3, these are the tap sets. Whenever somebody want to purchase a tap set, normally the people will purchase in a set. It will come as a set. Normally you can also purchase nowadays, because the materials technology developed, so you can even go for a single tap, but advisable is you should go for a tap set. So one can generate the external as well as internal. This is how the external threadings will be done. And this is how internal threads. Okay, so this is how the internal as well as external threads are generated. Okay, so now we will move on to the basic thing, that is how the handheld tapping process is work. So this is how the tap will be. Normally the tap geometry will be like a cutting edge will be there on the edge, heel, this is particular thing is the land, how much width is there, that is the thing about the land. Everything you here also you will get a relief, normally that is called a chamfer relief, and you will also have certain rake angle here, and you will also have the flute, so that the chips will come out whenever whatever generated there, it has a provision to send it out. So you can see the flute here. These are the flutes where through whatever the things that are coming here, it will come when along with the lubricant or along with the cutting fluid that are used here. You can generate 2 types of taps or threadings, that is called through threadings also you can do, and bottom tap also you can do, where you can terminate at certain distance itself. So there are varieties of threadings you can do here. Hand taps, the first one is the taper tap. I said there are a set of taps will be there. Normally a tap set will contain 3, which you have seen in the previous slide. So among that one, whenever I want to generate a particular thread, assume that I want to generate M10. For that particular, normally the prerequisite is you should have a drilled or reamed hole. First you do the drilling operation, then you do the reaming operation, then you go and use the first one is taper tap. So you may not go for 10 mm hole, you can go for 9.8 or 9.75 or something, so that this taper will be there, this particular taper which is there can penetrate at the initial stage, so that it will, once you twist on, it will gradually enter into the workpiece. Okay. Chamfer normally lead 7 to 10 threads at the 5 degrees per side. You can see here 7 to 10 threads are there, which are chamfer will be there. Okay. That means that there will be some taperness will be there. The taper lead distributes the cutting forces over the large area, and the taper shape helps the thread to start. That means that if I have a 9.8 mm hole, this taper will help me in positioning at the initial stage. Okay. Let me position first, then you can generate the threads. Okay. So used for starting a thread prior to use the second and bottom. So there are other 2 taps, before that one you have to use it. That means that I have a 9.8 mm hole where I use the taper tap, and I just generated a initial threading before I go for second and third taps. Okay. Once I complete the taper tap, I will move on to the second one, that is called plug tap or the second tap, which is here instead of 7 there, here you will have 3 to 5 threads will have chamfer, and use through holes, or you can also generate the blind holes where the threads are not need to go to the right bottom. That means that you can also go for the blind holes also, where blind hold threads also. And what is the point here to be noted is that you have to use this particular one after your taper tap. Okay, so taper tap followed by the plug tap, then followed by the third one, that is called bottoming up tap. Okay, so chamfer, normally here it will be 1 to 2 threads, and angle of the lead being around 18 degrees per side and used to produce close to the bottom of the blind holes. Normally, if at all I want to generate a perfectly threads across the cross section of the workpiece, that means that I want the through threads of the workpiece completely. In that circumstances, I have to use this particular thing. That means first taper will be there, then the plug will be there, then bottoming tap will be there, so that you will get the perfect throughout M10. That means that it will have M10 generating threads on this one. This is about the 3 varieties in a tap set: taper, plug and bottoming taps. Okay. You can also generate these threadings by using the machining. There you can hold the tap in the machine and you can also use it. For that purpose, there are different types of taps are there. Whatever we have seen, the 3 varieties which are in the previous slides, those are the handheld. Here whatever you are seeing is a machine held. Okay, designed for higher speed and need less power than the handheld taps, because these are all designed for higher speed, so you can generate at higher speeds. I mean to say not very high speeds compared to the hand, because in a hand you can rotate at certain speed. Here you can still more, you can use the higher speeds for better production rates. Okay, so for that purpose, normally you can use the machine taps. Use for the machine tap for through holes or blind holes. You can use these machine taps to generate either through threads or blind hole, or the threads that are developed in the blind holes also. Okay, that is the beauty about the machine taps. Cutting fluids are the machine fluids in the tapping. Normally the tapping, if you are rotating with the hand, the speed is very minimal. In that minimal speeds, the basic thing that you are going to use is lubricant type. Okay, you can see here the first lubricant will be filled inside the workpiece, then the lubricant also will be applied on the periphery of the tap converse type of threads that are generated, and then you can do the threading operation. It can be machining based threads or the handheld threads. Most of the time it is suggested to go for the lubricant dominating, because the friction will be so high because of the low cutting speeds. So to counter it, obviously as a machining and manufacturing scientist or person, you can always prefer to the lubricant dominating mineral oil, pure mineral oils, rather than mixing with the water. But as I said, for the economy point of view, if there is a generation of any heat or something, minute heats, you can also use emulsions, but the emulsions you can go for 1:1 or 1:2, not more than that one. That is suggesting for the generation of low speed tapping processes. Okay. Now we move on to the knurling process, where knurling is nothing but embossing of diamond cone pattern or some other pattern for the gripping purpose. Okay. Introduction to knurling process. Normally process of embossing the diamond or straight shaped pattern onto the workpiece, that is called the knurling process. It improves the appearance of the workpiece. It can give good aesthetics to the workpiece. At the same time, provide better gripping. This is the major advantage or major application of the knurling process, is to have the grip. Normally whenever you see our homes, locking systems and all those things will also have the gripping. if it is in cylindrical shapes and all those things. So you can use for those grippings the knurling process. Okay. So in case of the workpiece diameter, when it press fit required, normally if at all I want for the press fit, so if you can use the knurling process, what will happen? It is a metal deforming process, because of which the dimensions will slightly change and then you can fit it perfectly. Special tool that is called knurling tool is used for this particular operation. Whatever you are seeing here, these are all knurling tools. Okay, this is the tool holder, how the knurling tools are held. Tool consists of straight shank fitted with 1 or 2 knurling wheels. These are the knurling wheels or the knurling tools. These are held in the shank. This is the tool holder or a tool shank. Job is held in the chuck and tool is fed across the job, pressing against. That means that you will press and then you rotate the workpiece. In a lathe, in the tool post, you can hold the knurling shank where the knurling wheel is mounted. Multiple knurling wheels also you can mount. Then you just give some depth of cut. Then you rotate the workpiece. You will get the knurling operation. So in this case, tool is not withdrawn till the process is completed. Normally you can complete this process in 2-3 passes if required, and speed should be completely low. Normally the knurling process where you are embossing. Embossing means you are printing some pattern on it. Assume that if a 1 rupee coin or 2 rupee coins are there, if you have, normally it will be a blank. So when you just print certain our symbols, national symbols, whatever the Indian government symbols or what are things are there, just their die, converse die will be there, just go and emboss on top of it. That is nothing but the embossing. In case of that one, if you are embossing a diamond cone pattern or a straight line patterns or cross hatch patterns, that is nothing but the knurling process. Okay. So knurling operation on lathe, if you see, just now I was explaining, you will have the workpiece. This is the workpiece. This is the movement of the depth. This is the knurling tool will be there. Okay. This is the tool post and this is the holder or a shank. Okay. So you can feed and you can rotate the workpiece by giving the cutting speed to the headstock. So the pattern is generated. This pattern will have a proper gripping if you are going for some of the grip applications and all those things. Grip applications are very useful in daily life of a human, especially in terms of sports and all those places to grip the weightlifting rod and all those things. There are 3 types of knurling can be done, that is called straight, diamond as well as diagonal. So diamond and straight pattern rolls are available in 3 styles, that is called, you can generate fine, medium and coarse type of things also you can generate. The people here, one suggestion for those people who are doing the PhD or the masters, they can go for fine knurling operation on a surface and you can change the contact angle of the surface. Okay. So 2 things you can try out here. One is you can try out the contact angle where you may generate the hydrophobic surface or hydrophilic surface, and you can use it for the biomedical applications for the implants and all those things. The second thing is you can generate the knurling operation, then you can cut using the machining operation. Normal cutting, knurling and cutting, you can see there will be a drastic change in the cutting forces and the cutting may be easy in the second case. There are certain papers where they are generating certain grooves on the workpiece, then they are cutting. So the cutting forces are gradually reducing. So the people can try these 2 aspects as a small part of your thesis. Okay. So let me repeat, you can change the surface engineering by fine knurling operation. If it is on a plate or if it is on a cylindrical surface, whatever you want to do. The second thing is that just generate the fine pattern, then you cut using the same cutting tool and you can compare with the normal turning operation. I mean to say, if you have take the cylinder, first generate the fine knurling operation and do the machining operation and measure the cutting forces as well as temperature. The same rod you can take on the other side, if you just rotate it, which is on the headstock or something, you just, the normal surface is there, you just do the turning operation and you may experience the forces difference. So you need to study more and more on the from the point of temperature, forces, surface morphology and all those things. Okay, these applications are very good from the point of biomedical applications, where if I want to machine a titanium or some type of materials, the temperature should not go very high, because titanium is not good conductor, so the temperature stays on the surface itself. Okay, so you can cut by generating some pattern on it, so that the temperature will be very less, so the metallurgical changes on the workpiece will not be so high. So this is a suggestion, may be used or may be neglected. So it is up, the ball is in your court now. So knurling, here knurling tool with one set of rolls is there, self-centering head will be there. Another one is knurling with a 3 sets of rolling or revolving head will be there. So here the difference between 1 and 2 is, here there is a fixed head in one, in the second one there is a revolving head. It not only revolve against the workpiece, but also it can revolve about its own axis also. Okay, if you see, there are different types of knurling wheels are there. These knurling wheels you can use single or you can use in a multiple also. So different patterns and different distances also you can generate. You can see the fine to coarse in this way. Here is a fine, this is medium and this is coarse. You can generate different types of knurling, and not only one, you can also use 2, so that you can generate cross hatch patterns and all those things. The lubrication in knurling operation. The knurling operation is very slow process. That's why you always go for mineral oil based cutting fluids, where the lubrication is dominating. Okay, so you need lubrication is dominating. Lubrication. That's why you always go for mineral oil based cutting fluids. You can also go for emulsions, but preference you can give for mineral oil. If you see the application, normally the application of knurling is most important from the point of sports, from the point of the people and all those things, where if you want to hold or the grip in the weightlifting, if you can see here how to, if a particular person is here, the particular person require a huge amount of grip, otherwise weightlifting rod may slip. So it is as dangerous as possible. That means that gripping plays a major role in the daily life of a human. Okay, you can see now this particular part is nothing but the clean and jerk of a weightlifting process or the weightlifting game, where heavy weights will be taken and you are having the proper grip on the rod, then only you can perform. Otherwise, it will be not safe from the game point of view. Okay, so hopefully the grip plays a major role in the weightlifting rod. In particularly, just it is one of the example. You can have the many examples, but you should generate the grip very sophisticatedly, depend on the application is concerned. Now we move on to the shaping process. Shaping process is a different process compared to the lathe. Whatever till now what we have seen is some of the accessories that you can mount on the lathe, then you can perform it. Now the shaping process is slightly different, which is some of the you know it about this process. Shaping, this is the shaping process where you can give the cutting motion is provided to the tool and the feed motion is given to the workpiece. Basically you have a workpiece, this is the workpiece, and this will be provided the feed motion. It means that this type of motion will be given, and the cutter will be reciprocating like this. So cutter will reciprocate as well as the feed will be given to the workpiece. In that circumstances, the material removal takes place in the forward stroke. These all work on the quick return mechanisms. The quick return mechanism is one of the mechanisms that you may come across in the theory of machines and other courses, where in the forward stroke only it will cut, and in the return stroke there is no material removal and it will come at very faster rate. Okay. There will be three forces that is generating, that is called FC, FA and FP, where FR is nothing but in this shaping process there are three forces are generated which results in FR. So where FR is a resulting force or a resultant force, FC is the cutting force, FA is the feed force, as well as FP is the radial force. You can see here FA is in this direction, and FC, this is the cutting force, and FP, which is the radial force, and the feed force is in this direction. Three forces are there, and the cutting velocity will be given to the tool. Okay. So the velocity, if at all I want to calculate, because there is a quick return mechanism is involved, the velocity of forward stroke is different from reverse stroke. That's why you have to always be attentive in that circumstances. It cannot be L1 plus L2 by 2 or something. So you need to take many things here, where V equal to Ns 1 plus R by 2, where S is nothing but the stroke length, how much stroke it is moving, R is the quick return ratio, and N is the number of strokes per unit time. Okay. For unit time, how many number of strokes are taking place. These are all will give me the velocity in the shaping process. If you see the shaping process, there are many varieties of the shapes that one can generate. That is called facing on a top. This is one type of generation. Facing on a side, because this is the top surface. So it is done on the facing on the sideways, and some of the thing is you can also generate the slots where you can put the keyways and all those things. At the same time, you can also generate the steps also. These are the varieties of applications of the shaping process that one can generate. Now move on to another process, that is called planar process. This is similar to your shaping process, but only the motions are vice versa. Here the cutting motion will be given to the workpiece and the feed motion is given to the tool. Okay. So the planing machines are normally used for big workpieces. The shaping normally uses for the small workpieces. That is the only difference. If you see, the straight and flat surface is created on the both surfaces. Now in this particular slide, if you see here, the similarities between shaping and planing is explained. In the both shaping and planing, the straight and flat surface is created on the both surfaces. Interrupted cutting subjected to tool impact when entering the tool. That means that when the tool is starting its journey, what will happen? It have some impact on it. That means that there will be an impact load on it. So low cutting speeds are due to the start and stop mechanism, because at the start it will start from 0 and it has to go to 0 velocity. For that means normally this particular process will be conducted either shaping or a planing process at lower speeds. Okay. So typically tooling, single point tools which moves linearly relative to the workpiece in the both, either you are giving a cutting motion in shaping or whether you are giving a feeding motion in the planing, both are like linear motions for the shaping as well as planing. The difference, some of you may face the interviews in some of the jobs, mechanical oriented jobs. There, one of the common questions you may come across is what is the difference between shaping and planing. So people, many of you know it, but it is my responsibility to just remind you that here the cutting in the shaping, cutting motion will be given to the tool as well as feed motion will be given to the workpiece. In the planing, cutting motion is given to the workpiece and feed motion will be given to the tool. So that is vice versa in both cases. The shaping and planing these are the differences. First difference I already taught you, and the second thing, clamping of the workpiece is simple and easy in the shaping process. Workpiece setting require much and still skill is required because you are going to hold very big workpieces. Usually one tool is used in the shaper. Several tools may be used in the planing operation because your workpiece is so large. Normally used for smaller size workpieces. As I said, here heavier and coarse cuts you can go for the planing, and you can go for the very big workpieces. Machine is cheaper and requires less floor area. It requires more floor area. That means planing machine normally will be in big in size, and the shaping machine can be very small. Okay, that's why some of the colleges or the small engineering colleges, they will have for the demonstration shaping machine, but may not be planing machines. Normally the planing machines you can see in very big industries where you require to cut very big structures, especially like HAL, Hindustan Aeronautical Limited, where you have to cut some of the big shapes and so on. So R&D laboratories where they will deal with big workpieces or deal with the planing process. CNC planers, you can see how big these planer machines are. If you see in this picture, it may not look very big, but if you imagine that these are the big equipment where you have to mount the large workpieces to cut. So till now we have seen the multi-point cutting tool process as well as single point cutting tool process, those processes which are used in the lathe, as well as after the lathe we moved on to the shaping, planing in this particular class. Now we see this summary of the today's class. We have studied about some of the single point operations or single point cutting tool operations in the machining processes. Since we have already seen in an elaborative way about the turning process, now in this class we have seen some of the single point turning processes or the single point machining processes, such as the boring process, shaping process, planing process, threading process, and some of the multi-point cutting tool process also, like tapping process, and mostly we have also seen about the knurling process. Okay, this is about the today's lecture that we have seen, and we will see about the other multi-point cutting tool operations in the upcoming classes. Okay, and followed by the abrasive processes such as grinding, lapping, and all those things. Okay, so in the next class we will see about the multi-point cutting tool operations, then followed by the abrasive processes. And I want to say at this particular moment of time, so what is the importance of knurling, since you have already seen a video in the when I was teaching the knurling operation. If you see, the knurling is most important and all those things. Now you can see my own video, because at that point of time I have not told you to not disturb you in the middle of the class. And when I was a student at some other IIT, that is IIT Kanpur, so I have been a record of player of weightlifting and bodybuilding team. So let me show my own experience, because how the knurling plays an important role in gripping the weightlifting rod. Okay. So now you can see how much important it is from the point of weightlifting, because if there is a small slippery on the rod of the weightlifting, heavy weights are pulled against the gravity and all those things. The fast pulling as well as properly gripping and all those things play important role. For all these things, knurling is one of the operations that will give you the proper gripping. Thank you.